Welcome. Hi. Hi, please take your seats if you're going to sit. And if you're not, please take your stand. Thank you. Welcome. Welcome to this place where the Wabanaki gathered for generations. Here, by the mudflats out in the harbor that they knew as the Clambake Place. Located here in what they thought of and still think of as the Dawn Land. This region in which they are still very active and sovereign nations who are leading us in working on issues like the stewardship of the Penobscot River and the ecological crisis of climate change. My name is Gray Cox. I teach in the Human Ecology program here at the College of the Atlantic with courses in philosophy, peace studies, language learning, and artificial intelligence. And I am very much looking forward to this session this morning on artificial intelligence, promises, and perils. It forms part of this 2023 Summer Institute sponsored by the College of the Atlantic in collaboration with the National Geographic Society. I'm looking forward to this in part because artificial intelligence is not just a hot topic in the news of the day. It is a technology that is fundamentally transforming our global ecological system. In the compelling phrases that IBM first used to call attention to this in 2008, there is a quest on a hyper-industrial level to make every aspect of every process on this planet be instrumented for monitor and control, and interconnected for systematic coordination, and intelligent through AI that can make this a smarter planet. This is a transformation that promises virtually unlimited and, in some sense, literally unimaginable progress. But it also may threaten us with potentially unsustainable and perhaps even unsurvivable social and ecological disruptions and disasters. So, topics of interest. But I'm also looking forward to this session even more because I believe this session will explore ways our understandings of artificial intelligence can be fundamentally enriched by studies of the diverse natural intelligences that we find in other organisms, as well as in the diverse forms of intelligence to be found amongst us as humans. What are the core meanings and characteristics of intelligence? And the boundaries between mind, brain, machine. How can we gauge intelligence in humans, and animals, or machines? What are the ethical implications of all this? Where are the relationships and what are they between tool use, theory of mind, consciousness, communication, and intelligences? And how might artificial intelligence improve our understanding of what it means to be an intelligent animal and a human being? It is my hope that the discussion may even cast light on what may be the central question of our time. How can AI and other forms of intelligence help us create not just a smarter planet, but a genuinely wiser Earth? I have the pleasure of introducing your moderator and host for this session, who will then introduce the other two participants. Amanda Stent has a doctorate in computer science from Rochester University. In previous roles at Bloomberg, Yahoo, and AT&T Labs, she has made significant contributions to the advancement of natural language processing. She's the author of Natural Language Generation in Interactive Systems and The Princess at the Keyboard, Why Girls Should Become Computer Scientists. She's authored numerous papers and technical reports and holds over 30 patents. Her expertise extends to areas such as machine learning, information retrieval, and computational linguistics. Additionally, she has actively served in major leadership roles in the profession. In her latest role as the inaugural director of the Davis Institute for AI at Colby College, she's playing a leading role in American higher education by pursuing a vision for including all the liberal arts in the study of AI in a way that I believe will further an understanding increasingly of a human ecological understanding of both the promises and the perils of AI. I can't wait. And I don't need to. Please join me in welcoming Amanda Stent.
Thank you. And I would like to welcome to the stage Christian Rutz and Thom Klepach. If you'd like to come up, we represent human, animal, and machine, and we'll just go ahead and get started. All right. I'm going to start with letting Thom introduce himself. Thom is my colleague at Colby College, where, among other things, he teaches consciousness studies and biology, and has taken students to, last spring, took students to an escape room and then a sensory isolation tank to help them think about problem solving and intelligence in human beings. Thom.
Hi. Well, I'm a biophysicist whose initial work, my early work, was driven by the question of what is the biological origin of consciousness? What is it about matter that makes it able to have sentience or subjective experience? And then what is it about biology that's taken advantage of that and created sentience in all the many ways that we find it manifest on the planet?
So we already have all the magic words that we're going to try to fill with meaning during this session: intelligence, consciousness, sentience, humans, animals, machines. I would like to introduce Christian Rutz. He's a professor at St. Andrews. I apologize, I'm struggling with this particular physical instantiation of a microphone, and I'm just going to try to project really loud. Christian studies corvids and communication and tool use in corvids and the intelligence in this family of birds. So Christian has some great videos to show us, but would you like to say a little more about your research?
Thanks, Amanda. Actually, my current work is concerned with investigating human-wildlife interactions and figuring out how we can best share space on an increasingly crowded planet. But as Amanda said, I've been doing some work on crows for actually the last 20 years. And I studied two species of crow that have the curious habit of using tools for foraging rather than their bills like other crows would do. And I've prepared two videos for you so you can see the behavior for yourself. I hope they are ready to play. They should show up on these screens here. This is the New Caledonian crow that lives on an archipelago in the South Pacific, an island called New Caledonia. And these birds use sticks and other pieces of plant material to extract grubs and other insect prey that are hiding in dead wood and in vegetation. And they are not primates, so they don't use their hands for using tools. They use their bills. You see it shortens the stick. It was a touch too long. What's hiding in this burrow there is the grub of a longhorn beetle. It's a larva that eats wood, and it has these powerful mandibles. And the crow is teasing the larva and tries to provoke a bite response so that it attaches itself to the tip of the tool. There's a second crow that is really interested in what's going on here. You see this targeted touching of the face mask. Now it got it out.
Ooh.
And
Yeah.
you see what a juicy reward that is for a crow. Now, if you think that is remarkable behavior, I want to show you another video which takes things to another level. There should be a second video here. This is a crow we tested in a field aviary we set up in New Caledonia. And we gave the bird a plant material we know it likes for making a very sophisticated kind of tool. It harvests a stem of this plant. And I will talk you through what's happening now. So it takes it to a safe perch again, it wants a tool for extracting food. In this case, it's meat, which we've hidden in little holes in a lock, which is placed in the aviary. It now starts crafting one end of this little branch into a hook. This is the nodal joint material where the side branch attached to the plant previously. And it now uses its bill as a pair of precision pliers to craft a hook from this nodal joint material. It's very careful not to remove too much material. It wants a really nice sharp hook. Now this hook is not a pre-existing feature of the plant. It's made by the crow, and you see how it does that. It now strips some of the bark. We think they do that deliberately to make the tip smoother, so it can be inserted more easily into holes and crevices. It now even bends the tool. We think we know why they do that, so it sits more ergonomically in the bill. And believe it or not, the New Caledonian crow is the only species we know of, other than humans, that has invented the hook. And as you all know, the invention of the hook was one of the major technological transitions in our own evolutionary history. So this is one of the big questions in my crow research. How did these crows on this remote tropical island start using tools? How did their technology advance from these very basic stick tools, which you saw in the first video with the larvae, to these very sophisticated hook tools? And then, of course, there is the question of whether they understand something about their tool behavior. How intelligent are they? What role does potentially communication play? And this is where this research interfaces with artificial intelligence research and machine learning, and I think we will cover that during our discussion today.
Thank you for those videos, Christian. I guess my first question to you and Thom, you use machine learning now to study the crow's use of tools and communication skills. Can you talk a little bit about how you use AI to do that? I'm also watching the crows and wondering how many times that crow saw that behavior before that crow was able to reproduce that behavior.
Yeah. The first question, how do we use AI at the moment simply as a tool, as a method? We suspect that these crows have quite unusual communication behavior. When you compare their vocalizations to those of crows that don't use tools, there are over 40 species of crows and ravens around the world. Only 2 of them are known to be tool users, the New Caledonian crow and the Hawaiian crow. When you compare their vocalizations, it's the tool users that stand out with really unusually rich vocal repertoires. And we use machine learning as a method for mapping their repertoires. Annotating audio recordings by hand takes hundreds and hundreds of hours. So it's very laborious using conventional methodologies. But there's also the risk that we may miss subtlety in the communication, which machines can see and uncover for us.
And how many times has that crow potentially seen that behavior?
We don't know, and this is another really exciting intersection with the field of studying the intelligence of machine systems. This bird was caught in the wild. We know it's an adult, but we don't know what this subject experienced during its life in the wild. We don't know, for example, whether it has seen other crows making and using these hook tools. And so when we do experiments with these birds, we have to make inferences about a really complex learning history. But I think machine learning and artificial intelligence potentially offers pathways for unpacking what might be happening in their brains.
Have any of these crows been reared in captivity that have demonstrated that behavior?
Yeah, so that's a really good point, Tom. We actually, many years ago, we hand-raised some of these New Caledonian crows in captivity, and we raised them in an environment where they could never see another crow or actually a human using tools. And so the question was whether these naive crows would spontaneously start making and using tools. And the answer is yes. So we saw that these chicks, without any sort of input, started picking up twigs and started inserting them into holes and expressing behavior that over the period of a couple of weeks led to functional tool behavior. But here's the really interesting thing. These crows got stuck at the use of basic stick tools, the kind of tools I showed you in the first video with the grubs, just a stick picked up from the forest floor. They would never make the really sophisticated hook tools. So it looks like on this basic genetic template, you need other sort of input. So that could be social learning. There might be a culture of making hooks that they have to pick up by looking at parents that make hooks. But yeah, so there's definitely a genetic template, but we suspect that on top of that, it's individual experience, it's social learning.
Mm-hmm.
So Thom and I and Christian have been talking since Monday about the nature of intelligence and communication and language, and how communication and language reflects intelligence and embodies intelligence, as well as questions like how much intelligence is baked in and what can you learn. Thom, would you like to comment on how language reflects intelligence and is used by intelligence in humans?
Yeah. So language is inherently an abstraction, right? It's an abstraction to a person like Douglas Hofstadter. There's this isomorphic mapping, that's the word he uses, but that is at the root of consciousness for him. In the booklet, I'll use this little quip here. Darren, when he introduced the Summer Institute, the topic exploration, he made the point that what distinguishes humans is our capacity for making sense of the world, and that distinguishes us from all other sentients. And I hope Crow's not going to put the hook on me here for disagreeing for that, or anyone to think I'm not grateful to be here. But I think that is wrong, because we just saw and we heard about these crows that were using language, and yeah, abstraction is an attempt to make sense of the world that we live in, right? You're observing the world, you're encoding it in some way, in an abstract way, you're communicating that. That's an attempt to understand your environment and to communicate with others. And there has to be some sort of concept of the other as well in that process. So yeah, humans, again, another point up that I think is worth making here. Humans tend to think of our intelligence as this pinnacle, and there's this hierarchy, this sort of linear hierarchy of intelligence. Yeah. And I think that is also not probably, I don't like that way of thinking about intelligence myself, because a crow, as we've seen, is really intelligent in its environment, and all sorts of animals are adapted to their environment and make sense of their environment using all kinds of abstractions. And language is an important part of that. Verbal language, vocal language is what humans like to focus on. But early work in chimpanzees, the chimpanzee Lana, that initially the Carters, I believe, were trying to get these chimpanzees to vocalize and communicate. And then it occurred to them that chimpanzees don't have the same vocal apparatus that humans have. But one thing that chimpanzees are really adept at is their manual dexterity. And so they thought, well, maybe these animals would be prime for sign language. And then once that happened, they expanded into this really large and nuanced vocabulary of sign language.
Yeah.
The thing that with these crows, one of the things that I think about, the naive crows were able to use sticks, but using the hook was a learned behavior.
Essentially,
Yeah, I wonder about the neuroplasticity aspect of this. You look at the auditory cortex of a trained musician, and that part of their brain is larger and more well connected than a person such as myself, for example, not a trained musician. But and likewise in these crows, they have the basic neural foundation for tool use, but that gets developed through use and application. The brain is essentially a muscle.
Probably, yeah. We don't know the details of that yet, but what we know is that a brain the size of a walnut can produce that behavior. And maybe I shouldn't say this, but my colleagues who study chimpanzees absolutely hate the crows, because it's the crows that make the hooks and not the chimpanzees. The assumption is usually that if you produce complex tools or this seemingly complex behavior, whatever it may be, that it requires a large brain. And here we have these birds with literally bird brains producing these highly sophisticated tools. And this is a question I'm really excited about. We've been wondering since we started working on these birds 20 years ago, what is the algorithm you need to produce this kind of behavior? What's the minimal set of structures you need to produce this behavior? And this is where I'm excited about the advent of AI, because you could potentially, in silico, simulate this. You could produce machines that can recreate this behavior. Maybe, Amanda, you can tell us a bit more how one could approach that.
Yeah, as I was watching that crow whittle that hook, I was thinking about the degrees of flexibility in the crow's physical infrastructure, the ability to symbol manipulate with beak and claws and its whole musculature, and comparing that with the relatively discretized or binarized ability to manipulate the world that even very advanced robots have today. Like, we could imagine a model like ChatGPT that you ask it to make a hook, and you give it a robot with a robotic arm, and you give it a beak, and I don't think it would make a hook. Even though it has read the whole web and has fairly sophisticated arm, I don't think it's capable, just the physicality of making that hook from that bark. So it's really a different kind of, it's like the machine has the ability to manipulate symbols but without intentionality or physicality, and the crow has the ability to manipulate the world, but I don't know if the crow has the ability to manipulate symbols in a way that the computer does or a human does.
Yeah, in introducing me, you referenced an activity that I did with my class that makes that vividly apparent. I take my class just as an example of the difference between AI and the term artificial general intelligence, which is commonly taken to mean the intelligence that a human has. We are generally intelligent, and we can apply our capacity in a wide range of environments. Just to make that vividly clear to them and frustrate them, which is kind of fun for me, I make them go into an escape room, and rather than just have fun figuring it out, they have to figure out how to use AI to solve the puzzles. Of course, they fail miserably, which is kind of fun. But
when your crows are communicating, do they use symbols to communicate, or is it primarily a physical method of communication?
So we hardly know anything about their communication system, except that it seems to a human observer unusually complex. And of course there is good evidence to show that human language co-evolved with our technical abilities. So to see the one tool-using crow having an unusually rich vocal repertoire is exciting to us scientists, because it points at a similar process of co-evolution of these two traits. And so we started off by simply mapping their repertoire. We tried to get an inventory of the different call types they use, and some of them are really subtle, really nuanced. The next step then, of course, is to attempt some sort of functional decoding. So we first do the repertoire, and we know they have, let's say, 30 or 50 or 100 different call types. But then the challenge is to make functional sense. What is the meaning of these different calls? And this is where it gets really exciting, I think, with the advent of machine learning as a research tool, because we can use these machine learning tools to look for associations between vocal output and behavior. We can search whether, for example, particular kinds of vocalizations are produced in the context of making tools or observing tool users. And we can then try and bit by bit decode what the crows have to say to each other, get a deeper insight into what part of their communication is actually tool related, if any.
Yeah. One of the things that we've been talking about, Thom mentioned the chimpanzees who have a lot of manual dexterity and can sign. And Thom, we saw the crows making tools with their very flexible beaks, and we've been talking on Monday and today about the way that the affordances available to us shape the intelligences that we have. Classic AI has this very human-centered, sort of platonic notion of intelligence. Intelligence is the ability to perceive the world, to represent the world, to reason, to learn, to act on the world. But all of those things are shaped by the embodiments that we have. So I wondered if you would like to comment on the way that we define intelligence and the way that intelligence is shaped by the embodiments that we have.
Yeah. So the term intelligence is a tricky one. It's like, to me, it's like the word natural. What does the word even, what does that word even mean? It can mean something in so many different contexts. And as I've said in our conversations here, it's only as meaningful as it is useful. So, I think, some of the talks that we have heard earlier in the week, where there is an understanding of different ways of knowing, different intelligences. We've heard about indigenous understanding of the land. For example, the Ojibwe word for green is water running upward, right? And that's that meaning. And they don't think in terms of nouns. It's more active verbs. And so that's a different way of knowing. That's a different way of being in the environment. So even amongst humans, the word intelligence it's not it shouldn't be thought of as a hierarchical thing. It needs to be thought of as an understanding of your environment and a relationship with your environment and how functional that is. So I think that placing humans on some sort of pinnacle of intelligence is really a misunderstanding of the power and potential of that term, right? Because understanding it differently will help humans to, I guess, to use Gray's term, help us create a wiser world, because there is a lot of intelligence, there's a lot of wisdom in the world, in these other creatures that we share the world with, and amongst the undervalued voices in our own population that really are important to the collective, to the whole.
I mean, in our Crow research, we actually avoid using the term intelligence altogether. When we watch this behavior, a natural response is, especially when you see it for the first time, to say, wow, that's smart, that's incredibly intelligent. But we struggle to define what exactly we mean by that, and it's also very difficult to know what's going on in the brain of another species we can't communicate with.
Yeah.
So we apply what's called Morgan's canon. We say, well, use the simple most explanation of the behavior you see this animal produce, and we try to tie it to specific, well-understood mechanisms. So I mentioned there could be genetic predispositions. Some of this behavior may actually be hardwired. It could be individually learned. It could be socially learned. So for us, the challenge is to decompose the behavior we observe these animals expressing into the constituent components. And that doesn't require us making any assumptions about how smart it is or how that intelligence relates to perhaps that of any other species. So we take a deliberately cautious approach with that.
So when you were talking about the deep learning models that you use to look at your crow videos, I asked you if you thought those models were intelligent, and you said, no, it's a tool. How many of you here think that crows are exhibiting intelligence when they are shaping these tools? Hands up. Okay, who thinks humans are intelligent? If you've interacted with a ChatGPT or a Stable Diffusion, a modern generative AI that produces pictures or text, hands up if you think those are intelligent. What about the smart speech recognition in your car? Matt. Okay, a bunch of skeptics about AI in the room here. So let's come back to what you were saying, and I would love Tom's comment. You were saying we can't inspect, or you would want to be able to inspect how the mechanism arises, right? We increasingly have difficulty inspecting how the mechanism arises with AI, but we also really cannot inspect today with any fidelity how it arises in us, which is my issue. Do you think it's necessary to understand how it happens to think a behavior is intelligent, or that there is sentience there? Or?
Well, the word intelligence, when it's being applied to computers, machines, is really there because humans are trying to connect and trying to see their reflection in this machine. And so we do like to think of ourselves as intelligent. Yeah, we've already pulled the crowd there. And so when we see behavior in a machine that is a reflection of our own behavior that we consider to be intelligent, then we label that as intelligence. And so there's one definition of intelligence, this sort of reflection of human behavior. You can take intelligence to be a proxy. Another definition would be intelligence as a proxy for awareness or sentience, consciousness, that intelligence is predicated upon a subjective experience in some sort of entity. And with that definition, that's why I waffled when you were asking, do I think my smartphone or my car or whatever, ChatGPT, is intelligent? Because on one hand, in that first definition, yes, they're incredibly intelligent. I mean, more intelligent than me, probably more intelligent than most people. However, in that second definition, I would say no, because I don't currently believe that any technological manifestation that we have right now is manifesting subjective experience. I don't think we've reached the singularity of sentient AI or sentient machines of any sort. That isn't to say that I don't think it's possible, because I do believe it's possible. And it's a larger discussion as to how I think that is the case and how that relates to embodiment. I am a scientist, and because of that, I'm a physicalist when it comes to consciousness. That is to say that I believe that consciousness somehow is related to matter, and there's different perspectives you can take on how that happens. And so depending on that, on your perspective, so for example, imagine that you were what would be called a scientific materialist. These are people that think that, the camps within scientific materialism would be like neurocomputationalists, people who think that the brain is just a kind of a big computer, and it's sort of emergent property complexity theorists. And these people, some of them, like that guy Blake Lemoine, that thought that lambda had become sentient, he would be one of those sort of complexity theorists who would say that ChatGPT or any of these things are experiencing something. And then another camp of physicalism is called scientific objectivism. And these are people who think that consciousness is somehow intrinsic to matter. And the consciousness that we see in biology through billions of years of evolution and development of all these complex biochemical structures, the biophysics of those structures has taken advantage of this fundamental property of matter and has given us this organismal consciousness. But there's something more fundamental to matter itself. And to really understand consciousness, you'll have to have a revision of our first principles in terms of physics that comes to an account of how consciousness is somehow part of that understanding. So to loop back to kind of the original question about embodiment in consciousness and computers and AI, I think it's possible that at some point humans will be able to devise systems that take advantage of the same sorts of things that biology has taken advantage of in different ways, in a different way. I don't think conscious AI will be necessarily biologic in the same way that we are. But
I know you said you also don't like the term consciousness necessarily.
No, but a point I wanted to make in response to Thomas, you said, how do we assess the intelligence of other organisms? It's very anthropocentric, very anthropomorphic. We view them through our human eyes. And I actually see huge opportunities for, again, using AI as a research tool for uncovering some of that richness and some of that diversity of other species intelligence, however defined. And I will give an example. We talked about animal communication, like what the crows say to each other. There is research underway where scientists try to decode the communication systems of a whole range of animals. And if you ask someone, which species have complex communication systems, most people would say, well, humpback whales, sperm whales, maybe parrots, maybe crows, a handful of species. And I think this reflects largely our own limited perceptive abilities and the limits of our imagination. Using machine learning, it is now possible to map the richness of the communication across of communication systems across the tree of life. And we can basically use it like a telescope. Some people compared AI in this context to the advent of space telescopes. People said, why do we need the Hubble telescope? What are we going to see? Well, it turns out when you point it at a seemingly empty part of the night sky, you see things you never knew were there. And you see unimagined things. And I think the same will happen in an animal behavior, animal communication context. Training the lens of AI on the communication of other species will show that many other species have very rich, very nuanced communication we weren't even aware of. Yeah. And I hope that knowledge, that increased knowledge and understanding will also drive and refresh empathy for the species we share this planet with, other species we share this planet with, and hopefully contribute to conservation efforts as well.
I think that was one thing Thom and Chris and I all agreed on, that we hope that using AI to better understand nature, and I would argue using nature to better inform the approaches we take to AI, for example, swarm intelligence, will help us to develop more empathy for the other species that surround us and a deeper understanding and sense of care for those species. I want to open up to the audience. I just want to make one comment as we do that. Christian mentioned modeling, being able to explain how behavior of a corvid develops. In AI, there's a very old joke that if you have a problem, you say you're going to need AI to solve it, you solve it, you understand how you solved it, so it's no longer AI. So it was a field that was constantly defining itself out of existence until now we have models so complex that we can't really necessarily explain what's going on in there. Now we really have AI.
Mm-hmm.
Yeah, so questions?
Here. See if we can get volume here. Yeah, right here.
Okay, yep.
My question is for Thom. I noticed in your bio in the program you mentioned you're using AI to address the brown-tailed moth infestations. Could you talk about that?
I'm sorry, I was laughing at the very, what was the question at the very end? You just wanted me to talk about brown-tailed moth? You just want to hear about it? Yeah. Well, yeah, brown-tailed moth for, who knows what brown-tailed moths are? Okay, most of you, good. Well, bad, I don't know. They are, for those who don't know, they're an invasive, a xenobiotic. The word invasive is such a loaded term, but they arrived on our shores in 1890s, and they're kind of the triple threat of what would be called an invasive, because they present both a ecological, economic, and human health impact. So it's like the perfect storm. It has all three of the sort of measures of a problematic species. No natural predators. They're unecologically annealed. So, and the outbreak has fluctuated over the last century, but Maine experienced a really, to use the local term, wicked outbreak in 2015 is when it really started getting going. And there's been a lot of work done. A woman named Eleanor Groden at UMO has done some amazing work looking at the various drivers of the outbreak. So you can take from that work and other studies that it's being driven by climate change, right? So our environment in Maine is becoming more like the natural habitat of where these moths come from. So we can expect some worsening outbreaks. And I am also a city councilor in the city of Waterville, where Colby College is. And as part of that, I have started this initiative trying to get the city to mitigate the effort. But one city can't do it alone. It has to be a regional effort. And our sister communities weren't really ready to commit the resources that I was able to talk Waterville into. So we're looking for ways, and here I'm getting to the AI, we're looking for ways to address the problem at low cost, right? So in the past, we have contracted arborists to go out and canvass the whole community, and we did a citizen science thing where residents were able to report brown-tailed moth on their property just to get as much data as we possibly could. And we had a very comprehensive map of brown-tailed moth infestation in Waterville. That cost quite a bit of money, actually. Waterville committed $100,000 in fiscal year 2020. And it was successful, right? It worked. for us. We were able to deploy all of this treatment for both public and private property. But as part of that, not every community can contract an arborist like that. So as part of that, we we contracted a guy to take a drone and capture all this drone footage above the same forest. And actually, Tahia is here somewhere. I don't know where she is. Raise your hand, Tahia. There Tahia is. Yeah, Tahia is the postdoc at the Davis AI Institute. She has been really sort of the brains behind using AI to analyze this drone imaging and benchmark it to the arborist, all of our ground level data, so that we can train a neural net to recognize where the moths are in that footage. And so then we just have a little software package that the goal is to have a software package where these communities can just get inexpensive drone footage and fly it over the affected area, use this software that we're hoping to develop here that uses AI to be able to identify infestation and propose different treatment strategies for mitigating the problem. So that's the way we've been using AI. Really the goal is to create a tool, a low-cost tool that can be used regionally to help deal with the problem for communities that don't want to spend all that money. I'll stop there.
Yes, I was wondering if you could think about insects and the work that Wilson did on ants. But recently in Scientific American there was an article about the possible sentience of bees and chemical communication. And is any work being done in using AI to investigate this type of communication?
So the question is about using AI to analyze communication and potential sentience in bee swarms, not necessarily the individual bee, but the whole swarm, but also potentially the individual bee. Christian, I don't know if you...
I'm aware of studies that use machine vision to look at swarm movements and coordination amongst individually marked bees. And so this is definitely something where machine learning plays a very important role. And of course, that work could be extended to attempt the kind of functional decoding I mentioned earlier, where first you map, you see what the patterns of movement, of the patterns of interaction are, and then through experimental investigation, you try to find out what they mean. And so I'm not aware of any ongoing study that looks at the sentience aspect you mentioned in an AI context, but I think it's just a matter of days or weeks until there will be one.
But I think there is something interesting in your question, which was also about the chemical signatures that they leave, and what Thom was just talking about, and what Christian looks at with the crows. We are, most of us, vision-centric. So we build AIs, we say, oh, I'm going to look at brown-tailed moths with computer vision. Oh, I'm going to look at bees with computer vision. Oh, I'm going to look at crows with computer vision. These three species have very different embodiments and very different primary senses than we do.
That's right.
And perhaps we should be developing AIs that build on their primary senses rather than ours.
Yeah. Ooh, here's Sylvia.
I'm intrigued by your linkage between consciousness and matter. And when I'm in the operating room about to operate on somebody, the anesthesiologist renders that person unconscious with drugs, and consciousness returns most of the time. When I am asleep, my wife would say, he's definitely unconscious, and yet my dreams are quite vivid, so there's something going on in there. So a couple questions. Number one, will AI help me to better understand what consciousness is someday? And B, I'm matter, and like all matter, I'm going to die someday. where does the consciousness go?
Yeah. You want me to take that? Great, great. Where do we go after we die? All right. Whew. Well, I'm glad you brought up anesthesiology, because that's one of the ways that consciousness is being experimentally explored, right? Anesthetics, for those who aren't specialists in the field, they're an amazing class of compounds because they have such a structurally diverse repertoire of anesthetics, right? There are other experimental paradigms that are being used, for example, are psychedelics that have suffered from stigma for a very long time, but are now being recognized, that understanding exactly what psychedelics are doing in the brain and how that's altering people's awareness, their consciousness. That's also part of various experimental protocols. I would refer you to the work of a guy named Stuart Hameroff and Roger Penrose. Yeah. I don't think they have everything quite right, but they are in this scientific objectivist camp that I was talking about, and I think that particularly Penrose's understanding of the collapse of the wave equation, I think, is very promising in terms of, because we're talking about like consciousness and how do we know if something's sentient, right? And then how that relates to intelligence. All of these different manifestations of the Turing test. Colby just hired a lovely researcher named Ben, I forget Ben's last name. Baker, yeah. He is a philosopher of the mind, and one of the things that he's working on is coming up with an improved Turing test that involves dance. That dance is a incredibly human way of interacting and telling if something is sentient. But all of this is really pretty inductive. It's all an inductive process of making these observations and then trying to come to some grand conclusion about whether something is conscious or not. And in the absence of consensus on a physical theory of why something is becoming conscious, we're never going to be able to get to a deductive state by identifying certain criteria in a system, in an artificial system, for example, identifying criteria and saying, these criteria are the predicates for subjective experience, are the predicates for consciousness in that entity. Am I dancing around your question too much there? Where consciousness... Oh, yes, you are. Yeah. Where does consciousness go when we die? The way in the Hameroff-Penrose model, it would be when you die, your biochemistry, degrades, and the wave equation decoheres, and it's lost. Like yesterday, we talked. There's so many beautiful things that came out of that talk yesterday, but Stan Robinson was talking about the entropy and the heat death, and that's life is a beautiful thing because it's finite. The other beautiful thing that I caught in that talk was the intergenerational compact of stewardship that the other speaker talked about. I think that is really important to what the three of us think up here.
Yeah, you also asked if AI can capture consciousness or...
Oh yeah, why don't you take that?
This session is called The Promises and Perils of AI, and the AIs that we build that reflect aspects of our perceptual abilities and our actuators, our ability to communicate, for example, those AIs are, sometimes I think that we are like Narcissus looking in a pool, and the AI is the pool, and the more advanced the AI becomes, the higher fidelity the pool, so that we fool ourselves to thinking that we are actually talking to ourselves, but we are just talking to a reflection. Today, AI is not conscious. I don't even know what consciousness is. The question is ill-defined. But if you were presented with an avatar of somebody that you know or knew, or a famous person that you wanted to meet, AI can increasingly render that avatar with great fidelity to fool you or me into thinking we are actually talking to that person. But that is a reflection of consciousness that is a terrible and potentially very dangerous imitation. And that's one of the risks. I mean, that's one of the long-term risks of AI. The near-term risks of AI are that we abuse people to build our AIs, and we abuse nature to maintain our AIs. But the long-term risks include that we fool ourselves into thinking that we are interacting with other human beings, and we give our empathy to those agents who do not deserve our empathy because they are not real. I don't know, Christian, if you had any comments on consciousness when we die.
Yeah, so there's this idea you just mentioned of interacting with other systems or other animals. I mean, this is where this field I mentioned of decoding non-human animal communication is heading, and it raises very important questions. Imagine we achieve that level of decoding that would allow us to initiate a meaningful conversation with another species. Do we have the right to do so? And what are the potentially unintended consequences? AI as a research tool may make that happen within a few years in some species. And I think we quite urgently need to have a conversation about the ethics of that. I will give you an example. I mean, I mentioned humpback whales earlier as a species that is well known for its very sophisticated singing behavior. It's known that this species can change within months on an ocean basin scale its singing behavior, and that's a natural process. It's called a song revolution. They start singing a new tune, and it's amazing, and it sweeps across the entire population. Imagine scientists try to have a conversation with a wild humpback whale and use a chatbot style setup and initiate that conversation, and that seeds a new song revolution, and we have forever altered that species' communication behavior. I think some of the opportunities are amazing. I'm particularly excited about the conservation benefits that could be derived from this research, but some of the unintended consequences are terrifying. And so as much as I enjoy these deep philosophical questions about whether it's conscious or not, there are some really urgent practical issues we need to tackle right now.
Very true. Thank you. Yes.
Speaking of dancing around the subject, which our last good doctor talked about, for those in the room who can remember the movie 2001, that's left a kind of a skepticism, cynicism, worry about this whole thing of hell in us. Does it fit into anything you're working on?
So the question is about the movie 2001, where I forget the name. I think it's Hal. Tells Dave. I want to get it right. It's not Dave telling Hal. It's Hal telling Dave that he cannot open the door to the spaceship, and Dave must stay out in space. And is there this existential risk of AI today? I mean, my answer is not in the short term. The risks there, everybody who's reading in the media about AGI and the risks of AGI is being given a snow job. The very real risks to AI today are that we are engaged in intellectual property theft at a grand scale, theft of wage work at a grand scale, and industrial capture, which is Meredith Whittaker's term from the White House Office of Science and Technology Policy, at a grand scale, and interfering in our society. Humans are using AI to interfere in our society at a grand scale, and those are the very real near-term risks. But I defer to you two as to the long-term risks.
You want to go first?
AI extinction, the
I
singularity.
see huge risks, and my colleague and collaborator Asa Raskin has publicly spoken about those over the last few months and has highlighted those. I think there is a real risk of these systems affecting the way we as humans lead our lives, the way we we affect the environment, the natural environment around us. And I think I'm worried about the fact that it might be too late to mitigate some of those risks. You say you're not worried. I'm very worried that it might already be too late to address some of these very urgent and very pressing problems.
Well, I'm glad that you mentioned the intellectual property risk, because it is so underappreciated, and it is such an important immediate concern. Yeah, I think you heard me say this earlier. My perspective on the risks of AI. I think the analogy I used in the room there was you can cut a carrot up with a kitchen knife, or you can cut the end of your fingertip up. It's how you use the tool as a reflection of the ethic behind it. Yeah. And that, in fact, what's called for, what humanity so desperately needs is self-reflection, both on the individual level, the communal level, the societal level, the civilizational level, this sort of self-reflection. Because the worst consequences of AI are really a result of the worst aspects of humanity. And you talk about displacement in the workforce. The workforce has always been shifting and changing, always will, since the beginning of work. However, when AI displaces a worker, if that's done putting profits above people and without an understanding of how it's impacting those who are interacting with the technology in a way that they can still maintain the dignity of work and a sustainable life, that's crucial, and that's why the Writers Guild is up in arms right now in Hollywood.
I can give you an example of the kind of thing that terrifies me. We've got two kids, they are 5 and 6 year old. I understand that these large language models, the cutting edge of that field, can generate speech that is identical to how my 5 and 6 year old talk with a 20-second sample. So now imagine what somebody could do with that tool. They could generate a phone call to me. And I believe it's my daughter calling me, my 6-year-old daughter, or whatever. And I leave it to you to imagine all the other ways in which these technologies could be abused. And this is not a question about whether it's conscious or not. It's an extremely powerful tool that creates potential for abuse on a civilization scale that I personally find terrifying. And I say that as someone who is at the same time excited about the research potential, the discovery potential, the potential for leveraging these tools to generate benefit to humans and other species. But
I think, the shared word here is tool. These are tools that have tremendous potential, and we have to follow the intentionality or the lack of intentionality of the users of the tools. So if the AI synthesized voice, if the AI produced synthesized voice convinces you to send money to Paraguay or somewhere, the synthetic voice is not to blame. It has no intentionality. The person who created it is to blame, and those of us who failed to control the creation of it are
That's
to
right.
blame.
Yeah.
If I could add one sort of hopeful note to all this. One thing it does do, it certainly strains the credulous when you're interacting with digital media. But I had the beautiful fortune of getting to talk to Sylvia Earle for a moment last night, and I was talking about taking some students down to the Tektite site that was one of her early acts of heroism. And it made me tearful, and I started to cry thinking about how powerful a symbol that was. And she took my hand, she held my hand for a moment, and it just was such a beautiful human gesture. It was such a beautiful human gesture that if you're seeking truth, if you're seeking meaning, that it's always going to live in our direct human interactions, in our actual humanity. Truth starts in our humanity, and that's where its ultimate home is. And so maybe all these threats that you see, which are so real, they're so real, maybe it's going to help us understand the value of that kind of interaction. Sitting face to face, having a conversation that you'll remember your whole life.
Have you got? So I was handed the microphone to ask my question in the back here.
Oh, yes.
So it's prescient question. It's about the AI safety movement. I was just curious to hear the panelists' view on the difference between AI application and scientific process, given all the protocols and the restrictions and that have been set up over, centuries really of the scientific method, versus commercialization and the sort of lack of protocol around commercial use of AI. And I don't know that much about the AI safety movement, and maybe you do know more and can comment. But I was wondering what you thought of both AI safety movement and as it applies to commercial versus academic. And then the sub question is, what do you think about the idea of like an IAEA for AI? Because there's not just the United States, of course, there's maybe some nefarious actors out there that are pretty advanced as well. Thank you.
We were very lucky in the spring to host Sorel Friedler at Colby. Sorel was recently at the White House Office of Science and Technology Policy, working with the National AI Advisory Committee and thinking about the regulation of AI, the regulation of the technical development of AI, as well as the scientific development of AI. One of the points Sorel made was that different countries have different regulatory systems. So in the EU and China, their approaches to AI safety right now are around developing new regulation, whereas in the US, Sorel said, we already have laws that we can use to regulate AI. In large part in the US, the process has taken the form of civil litigation. For example, we have intellectual property laws. We need judges to interpret them. We have wage protection laws. We need the courts to interpret them in the context of AI. Not that we need to start from scratch and create a whole new regulatory system for AI. Coming from industry, I will say no company deploys an AI just like, hey, it's Monday morning, I can deploy this, because we are subject, every company is subject to regulation, as well as the very real threat of lawsuits and the super big threat of bad press. So companies that are developing AI commercially, especially these very large, very expensive AIs, do them in a very constrained context already. Not that there can't be many bad intentions, but companies inhabit a very constrained world already. Yeah. Any other comments on that?
I agree that we need legislative frameworks that apply on a global, international scale, and I think the only way to make progress with that is through cross-stakeholder consultation. So you mentioned industry, you mentioned academia, science. There's the engineers who work at the forefront of developing these tools, the ethics experts. We need all of these people to sit around a table and discuss what the best mechanisms are to use these tools, control and mitigate their risks. And then once that consultation has taken place, you can think about the right policy instruments for implementation, whether that is through a UN convention or some other mechanism to which a large number of countries could sign up. And I think that is the conversation we really urgently need.
Yeah. I would argue we also need the anthropologists who understand how things affect society, and the creatives among us who
Yeah.
can envision potential futures that those of us tied to the scientific method or the engineering method often have lost the ability to envision. So we need everybody to help us figure out the potential world we want to inhabit. There was a microphone at the front.
So my question is how this amazing new level of capability that humans have created can do what you were just referring to get to a better place in terms of our relationship with nature. This conversation began with a salute to crows. It hasn't been that long ago that it was considered exciting to discover that chimpanzees have society, they have faces, they have communication. Jane Goodall, 15 years getting to know one species very well, day and night. To get to know an octopus over 1 year, day and night, changed the attitude that some people have about intelligence in an invertebrate. And then there are all those other creatures. Don Griffin back in the 60s on the question of animal awareness. And more recently, Carl Safina, what do animals think and feel? What does a fish know? Another book. We're becoming increasingly aware that whales might be more valuable alive from what we can learn, not just about them, but from them. More valuable than pounds of meat or barrels of oil. Maybe the same is true of tuna or crazy shrimp like the mantis shrimp, like stomatopods that have remarkable senses, and so do all these other creatures, bats with sonar. But the question is, how can this amazing new capability that we have give us respect? You know, I almost want to say the intelligence of the planet, not the Gaia aspect, although some people do question, is there kind of a planetary intelligence to achieve stability through the immense diversity of life that holds the planet steady? Whether you call it consciousness, or whether you call it just cause and effect, the laws of nature that seek some kind of stable place. Anyway, I throw it back to you.
What a wonderful
Can we
question.
get to a better place?
Yeah, what a wonderful question about AI's capability to help us explore, which is really the subject of this week's seminar. Would you like it to expand on this notion of AI as a telescope turned on the planet?
Yeah, it's a beautiful way of framing it, like as a tool to just uncover the richness of other species' capabilities, and going back to something we discussed earlier, not necessarily through comparison to humans. We should move away from asking how similar is this crow or this chimpanzee to what we humans do. We should be excited about uncovering what other species in their own sensory worlds, in their own ways, how they experience this planet. And I just, as a thought experiment, I mentioned this idea of initiating a conversation with another animal, and I said maybe we shouldn't do that, or we should be very careful how we do that and in which context we do that. But as a thought experiment, imagine you could have a conversation with a whale, and you could ask it, what do you think about how we use the ocean? Does this shipping route work for you? And imagine you got an answer to that. And imagine that's not a positive one. That surely must send a wake-up call in our direction and make us realize that we very urgently must get our act together and must find ways of sharing space on this planet and looking after other species. Yeah.
Yeah, I think to add to that, in whatever, maybe more generally, in whatever way AI is able to help the intellectual, the emotional paradigm shift from extraction from the natural world to a mindset of gratitude, of amazement, of creativity, of imagination, of thankfulness. In whatever way AI is able to increase that capacity, to facilitate that emotional shift that needs to happen in all of us, individually and collectively, that in whatever way AI can help us get past what I think of as the radical cult of the individual that has arisen in the hearts of humans, and empowers our sense of the importance of the collective, both collective across humanity and collective across life, right? The thin blue covering on this ball of rock that is so special. So that's, you know, all the ways imagination can apply AI to that will enable that. And then further down the line, when machines do have subjective experience, suddenly we'll have partners and trying to understand exactly what it is that experience is and how that increases the palate. I mean, that's a pretty, it needs a lot of thought. It needs a lot of understanding about the life that we share currently before any of that that next step should be taken.
So we had a visiting artist at Colby this last year, Oscar Santian, whose art touches on the relationship between nature, humans, technology, AI. And he was asked to respond to Holt Island. I think it's maybe 10 feet wide. I don't know. It's off the coast of Maine. And he gave the island a voice, using the voices of the artists who bought the island in the early 1970s and their language, and connecting the island to sensor data, connecting that voice to sensor data collected from the island so that the island can tell us in a way that we understand what is happening to it. And I found I was privileged to be able to collaborate with him a little. I found the whole thing, I'm not an artist, very interesting. And I think that might be a little part of what we are talking about, that really brings in all the different ways of knowing that we have to use AI to help us explore, understand, and respond to the natural world around us. So thank you for that wonderful closing question. I'm going to turn it back over to you.
Thanks, Amanda, Tom, and Christian. That's a lot to take in before 10:20 in the morning, but a remarkable way to start the day. And I wanted to just close with three takeaways. Yesterday, Nirav talked about crowdedness, connectedness, and convergence, right? And talking about the density of people, the interconnectedness of people across great distances, and then the erasure of boundaries between human, animal, and virus, and that's what made viruses flourish. And I thought about it, it's also exactly what makes ideas flourish, and especially when you have an erasure between humans and machines around us. So the second thing is Christian talked about the rights and ethics around communicating with whales. Tomorrow morning, we're going to talk about the ethics of communicating within our own species out in North Sentinel Island. So come to that at 9 a.m. And explore this difficult concept of the ethics around contact with other elements of our own species. And then finally, and I think, Amanda, you set up a really useful way of understanding humans and our relationship to machines and non-human animals when you said, humans' ability to manipulate the physical world and our ability to manipulate symbols, they might not be unique, but they're extraordinary. They're definitely extraordinary. And on Thursday, we'll explore that, that recording of symbolic abstraction actually extends potentially 300,000 years ago to Homo naledi, before humans have even become anything. And then lastly, Christian described AI like a telescope, which was wonderful. And I would say that art is another telescope of understanding the world around us. And tonight, we'll talk with Andy Goldsworthy, who is someone that I think has an incredible ability to manipulate both the world around us and symbols. And so come tonight at 5. Come at 4:30 because it's going to be quite crowded. But come back and continue this amazing discussion of exploration. Thank you, everyone, for this morning.
Thank you.